Hey, just wanted to make a quick video here on the practice problems for this Basics of Algebra unit. So yeah, here we go. I don't think you'll have too much of a problem with any of these first, I don't know, 12 problems, but let's go through a couple of them. Remember, just substitute out the letters for the numbers. So you got 6 minus 6 minus z is 3 plus x is 6. All right, what do you got to do? Remember, we have to follow GEMDAS. So, is there any grouping symbols? Yes, there's these parentheses. And then you kind of start over. Is there any grouping symbols inside the grouping symbols? Yes, there is. So we do that next. 3 plus 6 is 9. So then we could just kind of update this. We get 6 minus 9. And so 6 minus 9 is negative 3. And now this part, I'm going to kind of rewrite this maybe. I'm just going to rewrite this here. This is 6 minus a negative 3. Remember, subtracting a negative is the same as adding a positive. Or you can think about this as distributing a negative 1. A negative 1 times negative 3 is positive 3. So this is going to be 6 plus 3, which is 9. Okay. I don't foresee you guys having too much of a problem with those. If you do, make sure you do a Zoom meet with me so we can go over it. Let's see. Let's do a harder one. Let's do 11 or 12. Let's do 12. So we're going to be distributing here both of these. So remember two things. We have to distribute this negative 4 both times and the x. Okay, so when you distribute, you can treat the numbers as normal and then just do the variables afterwards. So negative 4 times positive 2, that's negative 8. And then x times x is x squared. Okay, and then we do a second distribution. We get negative 4 times negative 1. That's positive 4. And then don't forget to bring the x. All right, and then we go over here, negative 9x, or let's just do negative 9 times positive 2. Well, that's negative 18. And then we get x times x, which is x squared. And then we do our second distribution, negative 9 times negative 3. A negative times a negative is a positive, so we get positive 27. And we don't forget to bring the x with. All right, now we got, these are like terms, so let's combine those. We get negative 26 x squared. And then these are like terms, the single x's, so we get plus 31x. There's our final answer. Okay, least common multiple. These are going to help you with here later. Right now I'm kind of giving you what the least common multiple of 8, 4, 16, and 2 is, which is 16. So then you go ahead and distribute. But later you're going to just see these problems without this 12 here, without this 16 here. And you could try to solve this by keeping them as fractions. And it will work if you do it that way. But it's going to be a lot more difficult. Okay, so being able to identify least common multiples is going to be pretty key. All right. So remember when we have, so these are basically your count by numbers, right? So your multiples of 7 are 7, 14, 21, 28, 35. So that's how you can figure these out. When you have one like these, it's kind of easier to find the least common multiple of the higher numbers and say if they work for the other ones. Okay, so you might recognize, because these are pretty high up there numbers, if we were to go through and do 8, 16, 24, it's going to take a while. We're going to notice that the least common multiple is actually 72, and then you check, does it work for 4? Is 72 divisible by 4? It is. So is 3, so is 2, so you know that is correct. All right, 3, 5, 9. That's going to be, again, if you look at these two, you know it's, if it has a 5 in it, it's going to be either 0 or a 5. So when's the only time that, not the only, but the quickest time that 9 is going to end, a multiple of 9 is going to end in 5 is going to be 45. And then you check, does 45 also work for 3? Yes, it does. Okay, hopefully that makes sense. I have at least one question on the test where you just have to find the least common multiple, because you're going to need to be able to do that in the upcoming weeks. And then these ones here, let's see. I think 16 looks like a more difficult one. So just remember, we have to distribute to each one of these terms, okay? Even if there was an extra one that was just plus y, let's say that's where this was at, you would have to distribute here. So it would just be 12 times 1, okay? Hopefully that wasn't confusing, but that is something that students a lot of times in the past forget to do that. Now, you can use your calculator here, right? You can do 12 times, and then you could use that n over d key that you have in your calculator. That's kind of like in the middle there. It's the second column, third button down. You can do that, but a faster way to do this is to just do 12 times 5 divided by 6. So 12 times 5 is 60, divided by 6 is 10. Okay? And then even an easier way to do that would be if you can kind of think about these cross canceling, like, so 6 goes into 12 2 times, and then you can do that number, whatever you figure that number out. So that would be 2 times 1. So that's going to be just negative 2, because that's negative. Okay? So hopefully that makes sense. So you can do, if I could cross cancel this like this, it would be 4 goes into 12 3 times. So then you do 3 times negative 1, which is negative 3. Okay? And you kind of have to start over. Now here, this 12s would cancel, right? So then it would be negative, or it would be 1 times negative 5, which is negative 5. Okay? But just to show you that it works both ways, if you did, look, if you went 12 times 5, well, that is 60. And then if you divide it by 12 again, you're going to get 5. And then just drop down that negative. Okay, so either way works, whatever way you want to do it. Or you could go the long way and use the calculator. If you want to, maybe you want to do it the fast way and then check it with the calculator, make sure you're doing it right. That would be a good idea. All right, now we have to combine like terms. We got a bunch of y terms, right? Negative 2, minus 3, minus 5. That's going to be negative 10. So we're going to have 10x minus 10y. Okay? All right. There is the practice problems. These are the only thing, so this is the only sheet that's like actually required for the grade. But I do want to show you some of these application problems. I want you guys to give these a shot. These are kind of meant for you to struggle with a little bit, play around with these a little bit, make you think. And I don't really want to give out a whole lot of answers with these. And while we're online, with only 2.5 hours a day, we probably won't do a whole lot with these, but I do want to show you some of these. So it looks like 1 and 2 are just problems that we've seen before. So let's look at these. So perimeter. Well, perimeter would be, it's just adding up the sides. So really all you have to do here is combine like terms, right? You got 1 that has an x squared, so that's going to be by itself. Then next you're going to look at the just x's. I got 3x and negative 2, so there's going to be just 1x. And then combine your constants, so that would be 8 plus 7 minus 2, so that's going to be plus 13. Okay, hopefully that makes sense. Let's see, what else we got? This is a square, so we could do this, you could count it up 4 times, or it'd be a lot easier to just do this, square it, which would really just mean 4z, and then you distribute and then combine like terms. Okay, there's a little, why don't you guys try number 7 on your own if you want to challenge yourself. I can link the answer in later.